Hello. These notes are starting on page 12 in your pre-algebra Unit 2B packet. At least it's page 12 this term. I guess that could change. There is another video posted that also talks about algebraic proportions about halfway into the video, but it doesn't use the same notes, and so I'm creating this short one that uses our same notes so that if you are absent, you have something to refer to. So in this case, we have some examples at the top of equal ratios, and we have worked with equal ratios. And we can see that the cross products are equal. We've worked a lot with that. And so we can use that same idea when there's variables. And so we've been doing that when there's just an x in one place, and only an x. But we can also do that when there's something like x plus 3 over 7 is equal to x minus 2 over 4. And so you might encounter problems that have fractions or decimals. That would be much more common in these problems. I have tried to carefully select so that we don't get a ton of those, but more than our usual. So don't be surprised by that. If you divide it and the decimal comes out nice and neatly and ends, you may give the decimal answer. If the decimal fills up the calculator screen and it does not divide nice and neatly, then if it's a non-terminating decimal, the decimal does not end, then I want you to give your answer as a fraction or an improper fraction. Pardon me. So let's take a look at this one. Step 1 is that we're going to cross multiply. Which should be our go-to anytime I see a proportion. So in this case, that's 4 times 3 is 12. Is equal to 2 times x minus 1. So I need the 2 to be multiplied times that entire x minus 1. So that's why I've placed it in parentheses, because remember the fraction bar is a grouping symbol. Step 2, I'm going to distribute. And some of you will become confident enough that you will distribute as you write down your cross products. But for now, I showed that on a separate step. So 12 is still 12. 2 times x, 2x, 2 times negative 1 is negative 2. And then from here, we just have a nice two-step equation. Our usual things to do, we're going to, in this case, add 2. Of course, to both sides, because I'm keeping that equation balanced. Or you could think of it as moving the 2. And then divide by 7. Divide by 2. My brain is ahead of me a little bit. So we get 7 is x, or x is 7. I could write it on either side. Okay, so we're taking that concept that we know about proportions and solving for the unknown. The problem just turns into a multi-step equation. All right, so that example, there's some examples on the front page of the assignment that are just simply cross multiply and divide, like you've probably done dozens of times now with your other assignments, maybe even hundreds of times. But then there are some on the back side of the assignments that become equations with variables on both sides. So I'm going to go there to show you a couple more examples, because I don't think this next page should give you too much difficulty. So the beginning of the next page, problems 1 through 5, are very straightforward, cross multiply and then divide, and that's all. They cross multiply to just be a one-step equation. Some of them do not have pretty answers though. I have warned you about that. For instance, number 4, when I cross multiply, I have 49 is equal to 8n. And we all are quite aware that 8 does not go evenly into 49. So it would be acceptable to simply say 49 over 8 is equal to n. Now, because 49/8 is a terminating decimal, if I type that in my calculator, what I get is 6.125. So the decimal ends, it doesn't keep going after that, so either of those answers are okay. I do not want you to round that to 613 or to just 6. All right, so either leave it in the fraction form, or because this decimal ends, you could give the entire decimal. All right, but just be aware, there will be some that don't come out to be integer answers. But let's look, as I mentioned, at the back side of the page. 6 through 10 are very much like the example that we just did together on the other page. But when we turn the page over, we start seeing ones where there are more variables. See, we only had one variable here. When we turn the page over, we start seeing that there are problems that have the variable in more than one place. Notice they are not always in the same fraction. They are not always in the bottom or the top. They could be in any number of places. So let's take a look at number 11 first. And this page will be an assignment to complete both sides, so this will be a few problems done for you. So remember, this is cross multiplication, so we're going to crisscross. So I'm going to go 7 times b minus 10 is equal to 9b. So the equal sign is between the cross products. So this then distributes 7b minus 70 is equal to 9b. And then I need to get my variables on the same side. And I'm going to, in this case, move them to the right because there are no constants on the right. So it's going to be a little shorter if I make the right side my variable side. So I'm going to subtract these 7b so that my b's will be on the same side. Or you can think of it as moving them to the other side, and when they cross the equal, they change their sign. 9 take away 7 is 2b. Then we're going to divide both sides by 2 to find out that negative 35 is equal to b. Or you could write b is equal to negative 35. Okay, so we only had to distribute on one side, but we did have variables on both sides of our equation. So I'm gonna go down to number 15 next. Actually, let's go ahead and make it 16. The reason I'm making it 16 is because starting with 16, you have to distribute in both directions. Still cross multiply, but you're going to have distributing to do on both sides. So I have 5 times r plus 5 is equal to 8 times r minus 9. So crisscross, not straight across, diagonals. And then distribute, so 5r plus 25. So 5 times r, 5 times 5. 8 times r, 8 times negative 9. And then I need to get those variables on the same side. Your choice. If you move them to the other side, we should still get the same answer. I do have different signs, so I subtracted them, and I had a bigger negative, so it is negative 3r. Don't forget that negative sign on the 72. We've dealt with that kind of thing before. And now I'm going to subtract 25 on both sides. I have negative 3r is equal to negative 97. And I'm kind of glad that I chose this one because we are so accustomed to things dividing nicely that sometimes when we get something that doesn't divide nicely, we second guess ourselves. So it even makes me look at it twice. 3 does not go into 97. I can leave this in a fraction, but I do need to clean it up a bit. And by that I mean there are 2 negatives in the fraction, and I need to simplify that to make it a positive. I do not want you to give me that answer as a decimal, because that decimal is non-terminating. It's repeating. Okay. So I don't want the repeating decimal. I just want you to leave it in a fraction. Okay, I'm going to show you one more example, and I'll show you what it might look like if you distribute as you write the problem down. All right, so this one I'm going to distribute as I write the problem down instead of writing that step with the parentheses. So before I do that, I'm going to go ahead and clear the screen just so it's not so busy. So pause it if you need to still write something down. So I'm going to take a look at number 17, and I'm going to cross multiply. And when I cross multiply, even though the 9 is down the bottom, think of it as if the 9 still go left to right for the one that has 2 terms. So 9 times p, 9p, 9 times 10 is 90. If you wrote 90 plus 9p, it would still be the same. But when the sign in the middle is negative, you have to be sure that you're putting the negative on the right thing. And so if you go left to right, you're going to be less likely to mess that up. So 8 times p is 8p, and 8 times negative 7 is negative 56. And that would not be the same if I wrote 56 minus 8p. So be cautious there. So now I'm going to get those p's on the same side by subtracting 8p. So now I have p plus 90 is equal to negative 56. And then I would subtract 90, trying to get that p by itself. In this case, we're going to have one fewer step because we don't need to divide. So I have p is equal to negative 146. Wow, that seems like a really giant number. And again, we don't always trust ourselves when we either see something that's messy or too big. So let's just test this one just to be sure. And to also show you, you can test your answers. The fraction answers are really kind of messy to test, but this won't be too bad. So negative 146 plus 10, negative 146 minus 7. So this would be negative 136 over negative 153. So then I could cross multiply with the 8 and the 9 and make sure that my cross products are equal. So when I crisscross this way and do 136 times 9, I get negative 1,224, and if I cross multiply this way, I also get negative 1,224. So it's the same. So even though this number is like, whew, it's so big, or am I sure that's right? It is right, okay? So it may not be a lot of fun to check some of them, and not that you're required to, but glad I chose a couple of them that I did because they might have been ones that you would have second-guessed yourself. So the process, very similar. Notice what I did here that was just a little bit different was that I did not write 9 parentheses p plus 10 and 8 parentheses p minus 7, but I still did distribute to both of these and both of these. So you're welcome to take that bit of a shortcut, but if you find that you're forgetting to distribute, then go back to writing the parentheses down. Okay, that's algebraic proportions. Good luck.